I guess unless RJ does something crazy impulsive over the next 20 minutes, this will be our last bald speaker of the day. That's, yeah, rounding out the trifecta.
Rounding out. That's very punny of you. Get it? Rounding out?
Yeah, it was unintentional. So, yes, I'm welcoming Colt McAnlis, who is going to be showing you some mind-bogglingly awesome tech around textures, which, you know, I did not think would be as fascinating as it was, but I learned a lot in this speech. I'm also not very smart.
You learned that I get angry very easily.
Yes.
That's what you learned.
Colt gets angry at bad texture compression, and he might be getting mad at you if you don't stay and watch this talk.
People are leaving already because they realize that this is going to
Alex, I see you. You got to take notes. All right. Well, then I guess we'll just...
I'm not giving you any free internet searches.
That's it. No free internet for you. Searches. All right.
Is that guy's name really Alex?
Yeah, he's
awesome.
on the games team. Okay. All right. Well, before too many other people get scared away, let's welcome Colt to the stage. Thank you.
Hello, everybody. It's getting to the end of the day. Yes. Who's excited for beer? You know, that's the most energy we've got out of this crowd all day. Caffeine, swag, nothing. Beer, boom. All right. I will be short and sweet today. Hello, I am Colt McAnlis, and I'm a games developer advocate at Google, which means while everyone else is off running, creating the next protein folder or search engine or trying to find ways to cure malaria in the Congo, I basically sit around and play Bejeweled all day, which is fantastic. This is a talk about wrangling your textures because, well, I got angry one day. You see, I found that the more and more games I downloaded, the more and more games did this stuff to me, which quite frankly is insulting, right? You end up downloading a game, some free game that advertises that the download is about 1.2 megs or 3 megs, and then all of a sudden you hit this and your phone turns into a brick for the next hour and a half while it downloads something, right? And of course, for most, who has had this experience lately? Everyone, look around in here. Keep your hands up, keep your hands up. Look around. Okay, if you're developing a game that does this, these people are upset with you. Your intentions are bad and you should feel bad. Hashtag Zoidberg, right? So the question, I didn't understand this, right? Like most games on the stores are 2D games. I should not have to download 50 megabytes worth of content to find some oscillation frequency for a bird. This is wrong. So I had to ask the question, what are you people doing? Right? I've been in the games industry for a long time, and I do understand that a large bulk of content does come from textures, but this is a little bit insane. So rather than just making guesses about things, I proposed a test. And I actually wrote a very large framework to analyze the top games in Google Play. So I actually downloaded a horde of the top free, top paid, and top grossing games. I ran them through a large analyzation suite, which effectively opened each one of them, decompiled the assets, and then did analysis on them to figure out where the content was actually going. Because again, what the hell are you people doing? Let's figure this out, right? This, of course, dumped out into files and files and files of data that I have scraped on your behalf to present today. And here's what I found. No big surprise, across the top free, top paid, and top grossing games, over 50% of the content comes from textures. Ta-da! OK, I'm done. We can go. No. Followed up there, number 2 is actually code, but this isn't a talk about code. That's going to be next time. You know what? Just watch my Twitter feed. You'll see more about that in the future. Anyhow, the weird thing about this is that you know, top paid had way more images than free, and of course, gross is some sort of weird mix between those two. So we'll get into that in a second. If we sort of drill down and we take a look at the image section by itself, this is what really started disturbing me. Is that if you look at the textures across all of these APKs, they're PNG files. Please raise your hand if you understand why this is a bad thing. Yay! Y'all my people. This is great. I'm speaking to a crowd of my own. This is all PNG data, which to me is just mind-blowing because I don't want to see a graph like this. What I hope to see when analyzing the top games in Google Play was a graph that looked like this. That 98% of them were GPU formatted textures, right? And only some small percentage that you have to use for icons or some UI element that's in JDK code is actually PNG files. If your asset allocation doesn't look like this, let's have a little chat, you and I. You see, non-GPU formatted textures hurt you in two primary ways. The first off is load time cost. When you have your assets texture compressed in PNG or JPEG or GIF or any of the other formats, you have to incur a cost to load that texture into memory, right? And you have to remember, these devices that we're running on are not powerhouses of modern computing. Okay? If anything, they're a nice focal lens into 10 years ago. These are low-powered chips that run low-frequency code, and you're having them run through tons of deflate and JPEG codecs to get your images into main memory. That's not going to result in a very awesome user experience for your user when they have to wait to load this. In fact, how many of you have profiled how long image loading takes in your code? Did it make you sad? The room has spoken. The second problem here is GPU residency costs. So yes, congratulations, your artist has exported a JPEG texture. Woohoo! That doesn't help you at all when your game's actually running. When the texture is decompressed, it's actually uploaded into memory in full 32 bits per pixel. And then it gets to the GPU and it's residing in 32 bits per pixel. So all of that compression that you're doing, your pipelines, your chains, doesn't help you at all once the game's into memory. And quite frankly, that's the most important part. For those of you actually writing code that runs on a plethora of devices out there, you know that the difference in 100 megs of RAM can actually exclude you from entering a region or a marketplace altogether. We're talking about not being able to run code on Google Glass because you have too many textures. Right? Think about that. And I understand that GPU formats are a little daunting to a lot of people, right? It's this weird sort of cryptic setup, and it's GPU specific a lot of the times. And this is what people normally think about when you say, I want a GPU formatted texture, right? They see ETC and ATC and PVRTC and DXT1, and their brain starts going, wait a minute, I don't know how to set up my distribution to make all that work. Listen, it doesn't have to start there. What most people don't understand is that there's actually very usable low bit density formats on the GPU. And most of them are actually 16 bits per pixel, right? So we have our basic 32 bit per pixel. Oh, and by the way, you don't have to use alpha on everything, just so you guys know that. 24 bits per pixel is actually pretty good. Following up with that, we have 4444, right? So 4 bits per pixel each channel, still 16 bits. 5551, I would actually like everyone in here to do a test across your assets for me. In fact, tell you what, if you guys do this test and tweet me the results, I will happily retweet it to everyone else. Go to your asset folder for your game and find out how many of them would be fine using binary-only alpha. Let me know. Good? Yes? I see some really puzzled faces and some people leaning over going like, will PR let us do that? I don't know. And then, of course, we have 565. Let's look at what these do. So obviously, we're looking at a modified bit format. 16-bit formats are really easy to do. In fact, get this. You can actually save your format still as PNG, but you can actually use a 16-bit header to load it into memory. So just keep your pipeline the same. Use, my analysis will still be wrong because it'll still say PNG, but hey, that's cool, right? So let's look at the quality of these. So matched up here is 32-bit per pixel, 8 bits a channel, 565, 5551, and 4444. The only one that you can actually see any visible difference on is 4444, and the only place you can really see it is in the gradient behind the parrot. The reason for this, of course, is the human eye picks up very well on patterns and smooth gradients, and the quantization going from 8 bits to 4 bits actually picks that up. However, if you will, put up your thumb and just block out that gradient part. Yep, everybody, thumbs up, everybody, come on. Beer's coming soon, just play along, right? Block out that gradient part, and I want you to look at the noise inside of that parrot. You can't tell a difference, right? There's so much noise and so many edges in that parrot that you can't actually tell that there's only 4 bits per channel in that area. This is what we should be thinking of when we're talking about 16 bits per pixel. The quality is actually really good. And of course, on the other side of the coin, here is our GPU-specific formats that scare a lot of people, right? DXT, ETC, and PVR. And of course, these don't really look any different than the 8888, and that's of course because they're engineered to do that, right? They rely on very human perceptual models for visualization. A lot of very smart people are paid a lot of smart money to figure this stuff out. People who have much more hair than I do, and quite frankly are a lot better looking than I am. Hopefully they will give talks like this in the future. And so here's the problem that here's what I hear from developers when I tell them this. Like, hey, you don't have to use 32 bits per pixel. You don't have to use PNG. They always draw me a diagram like this. And they say, hey, I'm a small indie developer. Quite frankly, I don't have the resources to manage all of the APKs that this requires. I don't want to have to create an APK for ETC and then one for PVR, right? Because the GPU chipsets change per device. And my answer to you is, you don't have to. You see, if you actually take the PNG file, so let's take just a cropping of that parrot's head. That's a 256 by 256 by 3-channel texture, so just RGB. The PNG output for that is 192K. The DXT1, PVR, and ETC are, of course, much lower than that. They're fixed-bit channel block formats, no big deal. If you add them together, it's only 80K. I'm going to say that again. If you add them together, it's only 80K. If there's nothing anyone learns from this or tweets from this talk, I want it to be that point right there, okay? Is that you can actually add up and distribute all 3 GPU compressed texture formats for your PNG file in a single APK, and it's still cheaper than distributing the single PNG. Can I get a round of applause for that? Tweet that. Tell your friends about that. Shame your artists into that. Shame your creative directors into that. Right? There's no reason to view APKs as having to be tied to the GPUs. These are intentionally GPU-specific formats. They're meant to be small. They're meant to be awesome. Please embrace them. But if you can't, and I know sometimes you won't, because sometimes you don't, if you have to have the PNGs, let's be smart about it. You guys like that, by the way? I gave that a little bit of time so everybody can see that. There's a TM on there. I read the news. I'm safe. Can't say that word. So if you have to use PNGs, let's be smart about it, folks. I want to show you something that hopefully will scare every one of you. I want you all to be afraid of this. So here is a 16 pixel, or 16 by 16 pixel red image, just a red square, right? 3 channels, 24 bits per pixel, right? I just went into Photoshop and I just hit File, Save As. Boom, that's it, done. 2.74K. 16 by 16. This is an icon. File, Save As, 2.74K. Now, if I do the smart thing and actually go File, Save for Web, right? Everyone know that that button is there? Please tell me you know that button is there. I actually get down to 121 bytes, which, quite frankly, is something I would expect to see, right? So this should scare you, because how many of you are absolutely sure that your artists are hitting Export for Web on every single one of your PNG files? One person, and you have a hat, so you know what? I don't trust your opinion. Gotta let it show. Gotta let it show. I'm bald to own it. So for those of you who aren't aware, PNG is actually a pretty complex format. It's actually a chunked file format, which means it's broken up into regions of data that have a little bit of header that describes what information's in it. And this, quite frankly, can be anything. It can be RGB data. It can actually contain meta information about where the picture was taken. Like some phones actually embed the GPS location of where the picture was taken in the PNG format. In addition to that, it's an alternate pixel format. So you can have like 1 bit per channel, 3 channel, or 2 bit per channel, 4 channel, or some weird combination of that. And finally, all of that data is actually thrown at a deflate algorithm, or I'll use gzip for the common term of it. And all of this is bundled together as a single PNG file. Here's why Photoshop actually had us do 2.7K for that single image. And that's because photo editing tools like to hide stuff in that chunked format. If you guys actually open up half of the PNGs, you'll find just whole sorts of stuff, just crazy things in there. I found in one PNG file there was a menu to the local Chinese restaurant. That may not be true, but if it is, that's pretty cool. I'm going to run this analysis in like a month and find that block somewhere. I know one of you are going to do it. One of you are going to do it now. It's like, I wonder if Colt will find this. I'll retweet that too, right? Now, obviously, we at Android realize this is a problem. We realize that stuff is hidden inside of these chunks, and we try to do the right thing on your behalf. The AAP tool, or Android Asset Packaging tool, when you actually do your builds, will go through in an attempt to try to strip out a lot of this information on your behalf. And you see it when you run the command line tool. You'll see packing all this information, and it does some fun stuff over there. But what is the AAP tool actually doing? Not as much as you would hope, actually. This is actually taken from our documentation. Effectively, what AAP will do is it will create a lossless optimization to your image only if your image uses less than 256 unique colors will it then convert it to a palletized image? Only if there's less than 256 colors, right? And when you think about all the images in your game, that might work. I didn't know how many times this was running, right? Because this seems like a pretty important step, but I wanted to see the effect of it on our ecosystem. So I went back to the data. I reran all of my tests where each one opened up the PNG file and checked the format. If this is running a lot, we would hypothetically see tons and tons and tons and tons of palletized indexed images, right? Let's look at it. This is what I found. Of a sampling, I'm not going to say how many files I opened or what it was, but of a sampling, here was the basic counts. So the first one, of course, is 32-bit RGBA at 30,000 images. That tells me that 30,000 images were not, they had more than 256 unique colors. It also told me that there's a lot of alpha being used in our games out there. You can see from the second row, this is the index textures. These are the ones that AAPT converted, or your artist did the right thing and actually ran through the entire chain to convert it out the right way. Okay? But of course, this is still only 18,000. It's almost half. Only half of this analysis was actually categorized the right way. What scares me about this analysis is this column down here, or this row down here, 24 bits per pixel. Only 1,000 images were 24 bits per pixel? Listen, I've looked at a lot of your guys' data assets. There is a lot more textures that don't need alpha that you guys are throwing in your texture packer output that's getting bundled with alpha. And what we're seeing here is a result of that. Not accurately separating out images into their opacity and non-opacity variants. And the problem is that you're then bloating your assets because of it. Anyone guilty of that? You didn't raise your hand. Smart. Oh, one guy. Props, dude. I would hit my chest, but there's a mic there. And of course, a bunch of other stuff under there. So basically, we can see from this that the AAP tool is doing a good job of catching these outliers and actually turning them into palletized index textures, which is great. But there's still more to do. You can't just rely on that. Everybody knows that if you really want to compress a PNG, tweet this. Someone tweet this. Please, somebody tweet this. I'll wait for you to get a phone out. Everybody knows that if you really want to compress a PNG file, you got to do something crazy. You have to start with your input image and apply a lossy preprocessor. Effectively, you have to take PNG and make it like a JPEG. You apply a lossy preprocessor, and then you pass it off to an algorithm that's going to produce a smaller gzip file. Believe it or not, gzip is actually not the only way to generate gzip files. And quite frankly, it actually does a pretty bad job of generating gzip files. There's actually other algorithms out there. 7-zip, fans of 7-zip. Round of applause. Yeah. 7-zip will regularly output gzip files smaller than gzip does. That's pretty cool. Anyone heard of Zoffly? Wow. We gotta work on that. Zoffly is a tool released from Google a couple years ago now that regularly produces smaller gzip files than 7-zip. Z-O-P-H, Z-O-F. You know what? I found our problem. I found our problem. Zoffly. It's like the Russian bread. Zoffly? Dan will get it. Great question. No more questions from the audience? I just want to point that out. I'll be in the back when that time happens. Anyhow, you want to apply a lossy precompressor. What this is going to do is effectively reduce the amount of dynamic range in your image. It's going to create a more quantized image that have similar colors. This, of course, is going to be eaten and taken apart by a better deflate algorithm, giving you a big explosion, better, small, compressed file. The best part of this is that you don't have to write any of this code by yourself. If you just do a simple Google, here, let me Google that for you. You will get a plethora, an overflow, a flood of tools out there that already do all of this for you. Round of applause if you're already using one of these tools in your pipeline. OK, I'm going to come back next year. I'm going to give this same talk. I expect the whole audience to be clapping when we do that. Can we agree to that? Round of applause. And there will still be no more questions in the live stream on that talk either. So the cool thing is just go out, just pick any one of these, and add it to your pipeline, and you're going to get better compression than already what you're doing. The analysis I'm seeing already shows that a lot of people aren't using this, because these tools are going to accurately analyze your content. It's going to figure out how many channels you really need. It's going to apply lossy preprocessors, better compressors. In fact, you'll see the Zoffly PNG. Where'd it go? Where'd it go? There it goes. That's how you spell Zoffly. So, yeah, you know what? Let me file a bug on that. So that's Zoffly PNG. That's actually going to apply Zoffly to the deflate section of your PNG compression. Of course, if that's too crazy, because each one of those has little variants and whatnot, I highly recommend just starting with a tool called script PNG. What script PNG will do is it'll provide a directory for you that you can download all of those other PNG compressors. And what it'll do is, given an image, it'll find the one that produces the best output. So it'll actually run your image through all 50 of those, if you want to produce and find the best compression. And that's the PNG file that'll get shipped out. You don't even got to do the hard work. You just got to set it up, and the artist hits the button, and it goes off its way. Round of applause for lazy artists. See, I know when I'm talking to my people when they applaud at lazy artists, right? This is the programmers in the house. So this is, OK, everything I talked about before this was OK. This is where I'm going to get really nerdy, just letting you guys know. So let's say you do all this. I'm going to let you know you're going to hit a point of diminishing return. It doesn't matter how much compression you add or how much lossless preprocessing or what format you do to it. You're going to hit a point of diminishing return that if you're only thinking in terms of images, you're never going to break that point. You have to think about the data that you're using, how you're using it to get better results. So I did some tests, OK? This is a sprite sheet I grabbed off the web. This is from Glitch. It was a game. It was a big MMO game online, and they actually went under and open sourced all their assets. So thank you to the Glitch people for open sourcing your content so I can use it in my talk. Round of applause for that. Beer got more applause, unfortunately. So anyhow, we see in our games lots of sprite sheets like this, right? The artists have hand-drawn some animation, and they export it out in this large matrix of information. And we see this over and over and over again, right? You've got a talking tiki head, or you have someone getting hit in the face with a pie. They just render out this content. And sometimes, each of the frames actually differ by a very small margin between the previous frames. And when you look at a sprite sheet like this, you go, well, it's good that they've at least packed it into an atlas, so we know that they're not wasting too many sprites. But there's still a lot of data here that we're not able to compress, even with GPU formats. And the problem is that there's lots of duplicate wasted pixels that sort of act as the border or the transparent area. In addition to this, there's lots of duplicate pixels between frames, right? This image moves very little between two frames. And so the question you should really be asking yourself is, well, wait a minute. This is effectively just a flipbook animation. Aren't there already compression formats out there that do that? And you're right. There's GIF, or GIF. I'm not getting in that war. There's H.264, and of course, there's WebM. These are codecs that are built to, of course, compress animated content. And they do one hell of a job at it, except for GIF. You just don't. Just don't. WebM, that's pretty good. The problem with these, though, is you can't really use them in games. So first off, once again, we're talking about lower-end hardware here. And unless you're using the H.264 hardware decoder for everything, you're going to hit a pretty hard burden decoding each one of your frames. Because every single frame of your animation has to be CPU decoded to a raw 32-bit texture in the CPU and then uploaded back to the GPU. So again, these only help you in distribution. They don't help you at all on the GPU, where the problem really exists, where the stability is really a problem. What you really want is a format that looks like this. You have some hyper-compressed format, and you can load it right into the CPU and maybe do some compression there. But really, you want it to go to the GPU in a super compressed form that has some information about these sprite sheets in a hyper-compact, decompressible form, so that you can actually decompress it in the pixel shader as you're rasterizing your quads. So there's no interim step here. There's no middle step. Everything happens in the pixel shader. There wasn't one out there, so I built one of these. It's called Crabby. It's on my GitHub page. You can see the URL at the bottom. It's going to be at the end of every slide. Effectively, what Crabby is a compressed texture format for GPU reconstruction. It's effectively built to minimize the amount of duplicate pixels in a sprite sheet. And the results are actually pretty cool, if I do say so myself. So how it works, we effectively take an input image like this, and we actually store unique 4x4 pixel blocks. So any duplicate pixel blocks get completely removed. We only create a pixel block palette from this. In addition to that, each one of the frames actually creates a frame texture that's a quarter resolution that provides an index to what pixel block that's actually going to use. All right? So pretty simple. We're effectively doing palletized indexing, but we're using it on blocks of pixels instead of single pixels, right? Pretty straightforward. I'm not a genius here, guys. I'm bald. Look at me. I don't do great things. I just read books. Okay? And the results are actually pretty good. So take this input image, right? So the source 32-bit per pixel image in distribution. So this is the PNG version of this file that has then been gzipped. Okay? So there's 2 compression algorithms going on there. 207K. However, when it's decompressed into CPU memory, so the minute you decompress that, 2.48 megs, uploaded to your GPU, 2.48 megs. Okay? When you run this through Crabby, you get 129K distribution, 364K in the GPU. Thank you. Yes. Yes. That guy. I'm going to swag you. All the swag I have. Do we have swag left? Still, you're awesome. Let's dig deeper. The way I actually output texture information from Crabby allows you to add further compression to it, right? So that raw, let me show you that raw palette texture again. See that raw palette texture? That's just output as a TGA file. You can actually then compress it with DXT or PVR or JPEG or GIF or whatever you want to. And the result for that gets you even smaller. So if we took just the raw 32-bit per pixel image and we just ran it through DXT1, just raw, we end up with about 319K in CPU memory. However, if we combine DXT compression plus the Crabby output, we hit 84K. Thank you. What I really hope comes out of Crabby, right now it's sort of a research project. I want all of you to go test it, break it, please, dear God, break the code. What I really hope comes out of this is we start looking at different ways to attack our texture problem. Right? It's not just about block formats. We can actually recompose all of this stuff in the GPU. And quite frankly, the tests I have show it's still running very performantly on all sorts of devices. And actually, if you guys would like to run tests, I'd love to hear your feedback on where it's falling. But 2.48 megs to 84K, that's a huge savings. That's the difference in running on every device and only devices in North America. Which is, if you listen to Bob Meese's talk earlier, is the difference in a lot of potential users. And the fact is that distribution and size of your assets do correlate to conversions and downloads. So with my analysis, these were the numbers I found. On average, the top free game was around 34 megs. Now, for those of you who know, the size of the APK limits are around 50 megs right now, and then you can use the OBB file if you want to get larger than that. And you see the OBBs down in top paid. On average, the top paid game is 125 megs. Average. If you just look at this graph, there's some pretty numbers here. But what you should really take away from this is that there is, in fact, a correlation of size of the assets the user has to load and the ability for it to be successful at a price point. Users who are expecting free content want to click a button and play now. They don't want to wait 20 minutes for a loading screen. And because of that, the content's got to be small, it's got to be tightly packed, and dear God, it has got to be awesome. Crabby allows you to hit that. Using GPU textures allows you to hit that. Doing better GPU compression allows you to hit that. If you only tweet 3 things from this talk today, tweet these 3 things. Number 1, replace your PNGs with GPU textures. Do it. Distribute all 3 of them in your APK. It's still going to be smaller than a PNG. Your users will thank you. Number 2, use advanced PNG compression for those that you cannot turn into GPU textures. Just go pick any from that matrix or use script PNG. Trust me, it's going to be awesome. And when in doubt, look for unique and awesome ways to compress your texture data further. Please, for the love of all that is holy, go to my GitHub page, grab Crabby, check it out. My name is Colt McAnlis. This is how you get a hold of me. I want to hear from you, and I'm going to be in the back after all this. Come find me. Let's talk. Thank you.